Hello friends, so I'm going to talk you through today our intro to the math problems that we do. So go to our Canvas homepage and you're going to click on this week page, so 10.5 through 10.8. Then you are going to click on the Intro to LT5a PDF. So you're going to download this file into Notability, or you want to put it wherever you have your practice packet. So I sent it to Notability since that's where I have my practice packet. And now it's right next to my Unit 2 practice packet, which is exactly what I want. And this is at the top of your paper. This is what you're going to see on your toolbox on your formative on Wednesday. So formative C is on Wednesday, and that's the one that's going to look exactly like your summative. So F net is equal to the sum of individual forces. That's like the equations that you write right here when you do your models. So you do rightward forces minus leftward forces, upward forces minus downward forces. F net equals ma. We got that last week from our Newton's second law lab, our forces in motion part 2 lab. Fg equals mg. Just as a reminder, Fg is another word for what? Force of gravity means the same thing as, I hope you're thinking, weight. And m is mass. So this is the mathematical relationship between weight and mass. So if you see in an LT5a problem that we're given something about weight, make sure you plug it in for force of gravity, not for mass. And then we have our g constant, which goes in right here. Okay, so first is just a single step problem, just kind of a typical, we're solving for one force. So I'm going to first write my F net equations for this FBD. So I do my rightward forces, so F pull, minus my leftward forces, force of friction. And these are not equal to 0. A lot of times we say like, oh, this is equal to 0. In the y direction, we do upward forces minus downward forces. And in this case, I notice 5,000 newtons and 5,000 newtons. These are equal. And so I can write that this whole quantity is equal to 0 newtons. So if I want to solve for the force of friction, I'm going to look at my two equations that I wrote, and I'm going to search for the variable force of friction. And I see that right here. So this is the equation that I am going to use. And I also know another one of these variables. Actually, I know two of these variables based on the given information in the problem. So you try to find what are those two given variables in the problem. There's one. And here's another. So our net force is this negative 10,000. It's very important that you plug in those negatives. And our pull force is 7,255 newtons. So then I just need to solve for that force of friction. I am going to add, or subtract, 7,255 from both sides. Again, that's something that if you struggle with on the formative, you can always ask me for help, or on the summative. Just ask for help and I will help you. I'll say subtract this first, then you're going to do this. So if I plug this into my calculator, I get negative 17,255. But reminder that negative is going to cancel. So really what I'm solving for is this magnitude, aka how big the force of friction is. But I know that the force of friction, based on my FBD, is to the left. And so that's how I solve with my success criteria solution, including units and direction. That's how I make sure that I show my direction, is just with an arrow. Okay, now this is another single step problem. And we are given a bunch of information. We're given 8,000 kilograms. Think about what variable is that? Something measured in kilograms. Reminder, units tell you what the quantity is. It's a mass. Then I have negative 0.75 meters per second squared. That's acceleration. And then I am looking for, the question is asking, what is the net force? So that is F sub net. So I need an equation that has F net, M, and A in it. So if I take a look at my equations, F net equals MA. I always start by writing my equation. Don't be that kid who gets a 2 because they didn't write equations. It's disappointing because you know the equation. All right, 800 kilograms and then negative 0.75. So again, I just plug that into my calculator, and I get that my F net is negative 600 newtons, which basically means that it's 600 newtons to the left because it's that negative direction. So these are the 3 steps. This is like the bare minimum of work that you need to show every single time. This is the bare minimum of work. If you skip one of these steps, you are not you're not showing evidence for all the success criteria. And if you don't show evidence for the success criteria, I cannot give you credit for that success criteria. That's a missing part. That's a missing success criteria. Okay, what is the mass of an 803.6 Newton person? So I'm only given one value, and it's something that kind of sounds like mass, right? This is a variable that is attached to the person. It describes the person. It's the same for the person. But I'm trying to solve for mass. And mass, remember, is measured in kilograms. So this being measured in newtons, this is that tricky concept of mass versus weight that we talked about at the beginning, that if you're given something that seems kind of like weight or mass, and it's measured in newtons, that means it's the force of gravity. So that number that we're given, and again, I need to write my equation. Even though it's at the top of my paper, I still need to write my equation every single time. And I plug in this value. You don't have to do the units. And I'm looking for the mass, and I actually know what G is. G is a constant of 9.8. That's the gravitational field strength. So then again, I do some math, plug it into my calculator, and I should get mass of 82 kilograms. So I just divided both sides by 9.8. This is my final answer. Wait, do I need a direction? No, I don't need a direction because mass is not a directional quantity. It's a scalar. It is not a vector. Okay, and again, number 3, bare minimum amount of work that I expect you to show. If you skip one of these steps, you are missing a success criteria, and if you do that more than once, you will get a 2 for something that maybe you could have done. Okay, these problems are single-step problems. We are going to start with some more complicated, different, more complex problems. So we're upping the difficulty in LT5a. It's not just going to be that type of problem. Okay. So the first step is drawing an FBD for most of these problems. So we have SpaceX rocket is launching into the air with an increasing speed while its rockets provide an upward force of 250,000 newtons. What is the net force? So this is what I'm looking for of the SpaceX rocket. I've got 10,000 kilograms. The units are whispering to me that this is mass. And I'm launching it into the air with an increasing speed, while its rockets provide an upward force. So there's an upward force from the rockets of 2,002. Man, I did it again. 250,000 newtons. Okay, so we're going to start with our FBD. The prompt tells us that there is an upward force from the rockets. And if you want to, write down what that value is. Now, we're on Earth, so we're still going to have a force of gravity. And I know that because my object is moving up, it's being launched into the air, and it's increasing speed, which means acceleration is in the same direction as velocity. That means that my net force must be up because acceleration in Fnet caused the acceleration to point up. So I actually don't have any horizontal forces in this example. But I do have some vertical forces, so I need to write my Fnet equation. I've got my rocket force minus my force of gravity, and that's probably not going to be equal to 0. That is what we are trying to solve for, is the net force. So on the side of your paper, you are going to see these questions. These questions are not going to be present when you go take the formative on LT5a on Wednesday. You have to ask yourself these questions. So what variable am I trying to solve for? F net. Write out your knowns you can determine from the questions. So this is like what you're given. So I'm given that F rocket is 250,000 newtons. I'm given that the mass is 10,000 kilograms. And that's really it. I'm just given those two. So what equation will I use to solve this problem? I have to use an equation that has F net in it. So I could use F net equals mass times acceleration, or I could use F net is equal to F rocket minus FG, which I wrote myself right here. Both of those equations have F net in them. But when I look at these two equations, I do know mass, I don't know acceleration, I want to know F net, So I'd have to solve for acceleration to be able to solve for F net, which I don't really know how to do with any of these equations up here. You know, this equation has F net equals ma. It has a in it, but I want to use that equation to solve for F net. So I can't solve for a using that equation. So I'm actually not going to use this equation, and I'm instead going to use this F net equals the rocket force minus the force of gravity. So I have the rocket force. I don't have F net, but I want to solve for it, so that's good that it's in my equation. So I'm going to need to solve for Fg before I can actually use that equation. And to solve for my force of gravity, I can use Fg equals mg. So that's my first step, is Fg equals mg. I know my mass is 10,000 kilograms. G is a constant, so it's always 9.8. And so Fg is going to be, I think 98,000. Yeah, 98,000. Okay, am I done? No, that wasn't the goal. The goal of the problem was to solve for F net. And so step number 2 is going to be to use this equation that I had to create based on my FBD. So now I have my rocket force that was given to me in the problem. I just solved for my force of gravity. And so I can solve for my net force. I plug it into my calculator, and I get 152,000 newtons. Make sure you put that unit on your answer. And then what direction is this net force? I already wrote it right here, but we can tell because that rocket force is a lot bigger than my force of gravity. Okay, now this next problem, I'm going to show you a different way to think through these problems. So these questions can be super helpful, but you need to remember all those questions. And I'm going to show you a trick that can help you when you get stuck and you don't remember what questions you're supposed to ask yourself, how you can kind of get yourself to ask those questions. Okay, so first step is FBD. I've got this number right away, a 117,600 Newton plane. So that is a variable that is attached to the plane, right? It describes the plane. It's used as an adjective here if you want to get all grammar nerdy. So what do you think this variable is? Like, which variable in these equations is that? It's force of gravity. So because it has a Newton unit, that whispers to me, I'm a force. It's not a mass value. It speeds up from rest on the runway, so we know our velocity and acceleration will be in the same direction because it's speeding up. The plane exerts a force of 70,000 newtons. So this is the force from the plane that allows it to accelerate at 8 meters per second squared. Notice too, so this is acceleration because it says accelerate at. Notice that this is a positive acceleration. What is the force of friction? So this is what we're looking for, is force of friction. of the road that the road provides against the plane. So my velocity, because I'm speeding up and I have a positive acceleration, right? 8 meters per second squared. It's not negative 8 meters per second squared. That means my velocity is also going to be positive because this problem told me that they're speeding up. That means F net is going to be to the right. And when I go to draw my FBD, this plane is accelerating horizontally. It hasn't actually left the ground yet. So the force from the plane is actually going to be this rightward force. And again, you can write in these values when you're given them. So 70,000 newtons. We want to know what the force of friction is. That's the one that we want to know. And we have our force of gravity, of course, because we're on Earth. But this plane is in contact with the ground, so there's actually an upward force acting too. And that's the normal force. And these are going to be equivalent. But hold on, I've got another known force value. Force of gravity. Okay, now I'm ready to write my F net equations. I like to always start with whatever, like the X or the Y direction, whichever one has a net force of 0, just because I think it's a little bit easier. So for F net Y, this is 0, is equal to 0. So I've got my normal force that's up, my force of gravity that's down, so I subtract it, and then that's all equal to 0. My F net X, I've got the force from the plane, subtract the force of friction, and that is not going to be equal to 0. So this is my trick, because right now I'm feeling kind of overwhelmed. I have a lot of information, but I don't know how to solve this problem. So we have 3 equations that we potentially could use to solve this problem. And these are the 3 equations that you always potentially could use. I need a little bit more room. So these are the 3 equations that you could use every single time. So if these are your 3 options, and you're going to have to use probably 2, maybe 3 of them to solve the problem, why not just start by writing all of them down? Students that I have seen who have done this have been very successful with these multi-step problems. And I think it's because you just have all these options now right in front of you. So this is another way of thinking about it instead of answering all these questions. So this F net equation is going to come from your model. F net equals ma, a classic. Fg equals mg makes you remember that force of gravity and mass are not the same thing, so you don't plug them in incorrectly. And I am just going to start to take my given information and try to plug stuff in. So I know the force of gravity. I don't know the mass, and I do know 9.8. So I could solve this right now for the mass, but let's see if I even need to. I don't know F net. I don't know mass. I do know acceleration, though. It's 8, not 0.8, right? Yes, it's 8 meters per second. So maybe I do need to solve for mass over here so I can get F net. We'll see. Over here, I want to solve for force of friction. I know the plane force is 70,000. And so I'm going to need to solve for the net force. So I'm going to start with Fg equals mg so I can solve for mass. If I can solve for it, I might as well solve for it. I just plug this into my calculator and I get a mass of the plane as 12,000 kilograms. So this was my step 1. Now I can take that mass and I can plug it in into this equation. And I get that my net force is 96,000 newtons, positive. So then I can plug that in to this equation. So this was my step 2. Now this is my step 3. And going from here, I'm going to subtract 70,000 from both sides. And I get that 26,000 newtons is equal to that force of friction.